Have you ever imagined what will be the result of feeding AI algorithms with not just human-generated data, but with data created by other AI systems? On one hand, we could see AI systems become even more intelligent, finding solutions to complex problems in ways that we might not even imagine. But on the other hand, this process could lead to unintended consequences. Let's dive into the details. AI's evolution towards learning from data. Over the past few decades, AI systems have been rapidly evolving and learning to perform tasks that were once thought impossible for machines. This revolution has largely been driven by a technique called machine learning, where algorithms are trained on vast amounts of data to detect patterns, make predictions, and perform tasks. At the heart of machine learning is the process of feeding large quantities of data to AI algorithms, allowing them to learn from this data and improve their performance over time. This data can come from various sources such as images, videos, text, and even audio recordings. To give you a better idea, consider the example of facial recognition technology. To train a facial recognition algorithm, developers feed it thousands or even millions of labeled images of human faces. The algorithm would then analyze these images, detecting patterns in the shapes, colors, and positions of various facial features. Over time, the algorithm becomes more accurate in recognizing human faces and can even learn to identify specific individuals. Similarly, machine learning is also used to teach AI to recognize speech, translate languages, predict stock prices, diagnose diseases, and much more. The possibilities are truly endless. However, machine learning is not just about feeding data to algorithms. A crucial component of this process is also the supervised or unsupervised nature of the learning. In supervised learning, the data is labeled with the correct answer. For instance, in the facial recognition example, they will label each image with the name of the person in the picture. This allows the algorithm to understand the relationship between the data, which is the image, and the correct answer, which is the person's name. In unsupervised learning, the data is not labeled, and the algorithm must discover patterns and relationships on its own. So you might be thinking, if we can already teach AI to perform all these amazing tasks using human-generated data, why bother with AI on AI learning? The answer lies in the vast potential of this process to unlock even greater levels of machine intelligence. With the incredible advances made by generative AI models like ChatGPT, DALL-E, and others, it's natural for the developers behind these systems to wonder if they can leverage their advanced capabilities even further by using the data they generate as training material for new AI systems. At first glance, this seems like a fantastic idea. After all, if these systems can already create incredibly realistic images, generate well-crafted text, or even perform complex reasoning, why not use their outputs to enhance the abilities of other AI systems? AI on AI learning. Yes, the idea of AI learning from AI is both intriguing and potentially revolutionary. When we talk about AI learning from AI, we're specifically referring to the process of using outputs generated by one AI system, such as ChatGPT or DALL-E, as training data for another AI system. While we agree with the fact that these AI unconsciously pick these data from what they see online, we have seen cases where some AI models are intentionally fed AI-generated data for training. For example, language models like GPT-4 are getting trained on outputs from other AI systems. Even in the world of art, platforms like DeviantArt allow AI-created artwork to be used as training data for newer AI models. No doubt this process has several advantages. For one, it allows us to rapidly generate large amounts of training data for new AI systems, which could help accelerate their development. Again, the training data generated by these AI systems could potentially be highly relevant and representative of the task at hand. After all, these systems have already demonstrated their ability to perform human-like tasks with a high degree of accuracy, which means that their outputs may be more useful and informative than human-generated data. However, this trend of AI learning from AI can lead to what researchers call model collapse. Possible outcomes. In a study unveiled in July 2023, researchers from Rice and Stanford University shed light on a concerning trend in AI development. Their report, titled "Self-Consuming Generative Models Go Mad," delved into the repercussions of training AI models, solely on outputs generated by other AI systems. Their findings were able to establish that when we train an AI model using data produced by other AI models, we essentially subject it to a distorted self-reflection. Think of it as a game of telephone, where each rendition of the AI-generated data drifts further from reality. What researchers discovered is that even a small infusion of AI-generated content in the training data can prove detrimental, leading the model's outputs to rapidly deteriorate into nonsensical jargon within just a few training cycles. This degradation occurs because the errors and biases present in synthetic data get magnified as the model learns from its own generated outputs. This issue of model collapse isn't confined to a specific type of AI model. It affects various models, including those for language and image generation. While larger and more sophisticated models may display a bit more resilience, there's little evidence to suggest they're immune to this phenomenon. With the increasing spread of AI-generated content online and in standard training datasets, future AI models are poised to be trained on a blend of authentic and synthetic data. This sets in motion an autophagous loop, where the model continuously consumes its outputs, steadily wiping the quality and diversity of its outputs over successive iterations. Taking their research even deeper, they delved into the intricate workings of self-consuming generative image models. These models, trained on their synthetic outputs, were subjected to a meticulous analysis that revealed intriguing insights into their behavior. The researchers identified 3 distinct types of self-consuming loops that these models can exhibit. Firstly, they discovered the existence of fully synthetic loops, in which models exclusively depend on synthetic data produced by their predecessors. However, this strategy frequently results in a phenomenon known as model autophagy disorder, MAD. MAD emerges as a gradual deterioration in either the accuracy or variety of the generated images as subsequent generations progress. This degradation can compromise the quality and utility of the model's output, highlighting the inherent challenges in relying solely on synthetic data for training. For instance, when 2 identical facial image generators were trained in fully synthetic loops, one machine was trained without any special rules, while the other was trained with certain preferences, like a favorite color or style. When they made pictures, the first machine without rules sometimes made weird patterns in the pictures, like ripples in water. But the second machine, with its preferences, kept making really good pictures. But they all started looking kind of the same, like they were copying each other. Secondly, there are synthetic augmentation loops, which involve the integration of a predetermined collection of authentic training data with synthetic data. Although this method may temporarily postpone the emergence of model-assisted degradation, MAD, by initially enhancing performance, over time, the synthetic data becomes predominant, resulting in a deterioration in either the quality or diversity of the dataset. Finally, they discovered one that had to do with fresh data loops, where each generation of the model gains exposure to an entirely new corpus of authentic training data previously unencountered. This innovative strategy emerges as a promising solution to the challenge of mode collapse, ensuring the sustained excellence and variety of generated images as the model evolves through subsequent iterations. The key lies in ensuring a continuous stream of updated real-world data with each generational cycle. Lacking a sufficient influx of new real data, generative models risk falling victim to mode collapse, where their outputs gradually diminish in both quality and diversity over time. Away from their findings, the struggle against the use of synthetic data has been a persistent challenge in the AI field. But recently, there has been a significant call to action from key players. This urgent cry for change was voiced during a gathering at the White House, where industry leaders committed to implementing measures like watermarking. Watermarking, a pioneering technique, involves digitally stamping synthetic content such as deepfake images or audio with technical markers. These markers act like fingerprints, enabling users to quickly distinguish synthetic data from real data, thus reducing the risk of misuse or manipulation. The primary goal of measures like watermarking is to mitigate the harmful effects that synthetic data can have on society and the internet landscape. In the case of model autophagy disorder, MAD, it is hoped that watermarking could serve as a preventative measure, making it more difficult for generative models to consume AI-generated data. While these strategies hold promise, there are still uncertainties about their efficacy in combating madness. Thorough research and experimentation are needed to determine whether they can effectively stave off this phenomenon or if alternative solutions must be sought. Researchers stress the critical role of maintaining a diverse and balanced mix of real and synthetic content in training datasets. This not only ensures the representation of minority groups, but also helps to prevent AI systems from producing biased or unreliable results. In the absence of diverse and representative data, AI systems can produce skewed outcomes that lack the nuance and flexibility of human decision-making. Moreover, the lack of adaptability in AI systems means that these biased or nonsensical outcomes can propagate, potentially leading to far-reaching consequences across different sectors, from content generation to decision-making in various domains. To combat this issue, companies must implement robust data governance policies that prioritize inclusivity and transparency. This includes actively seeking out diverse perspectives, ensuring that underrepresented data sources are included in the training process, and engaging in continual monitoring of AI outputs. However, this is not a simple task. If you have made it this far, let us know what you think in the comments section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.